In the last lecture, we've seen that the examples of how to find the homomorphism from Zm to Zn. Okay, so these are the two homeworks. Have you solved it? Find the group homomorphism from Z6 to Z4. Okay, so Z6, GCD of 6 and 4 is 2. So there are two homomorphisms from Z6 to Z4. Okay, solve के लिए कहे GCD of 6 and 12 is 6. So there are 6 homomorphisms exist from Z6 to Z12. Okay, नाही केलास ना. अजून एक example here. त्यानंतर पुढे जाऊया. Okay, find the group homomorphism from Z5 to Z5. ओके, अभ्यास करत चला, कारण की एग्जाम ऑनलाइन होईल का ऑफलाइन होईल हे अजून सांगता नाही येणार. ओके, फाइंड द ग्रुप होमोमॉर्फिझम फ्रॉम Z5 to Z5 and the group homomorphism from Z5 to Z5. Okay, now tell me, what is the GCD of 5 and 5?
5.
5. So there are 5 homomorphisms exist. Okay, 5 functions exist such that all the that function is homomorphism. Okay, now what are the elements in Z5? 0, 1, 2, 3, 4. Okay, now this is Z5 to Z5. Again, what is Z5? 0, 1, 2, 3, 4. What is the operation here? Addition modulo 5. Here again addition modulo 5. Now we have to find the functions such that that function is homomorphism. Okay, now what is the possibility? Here the 1 maps to 1. Okay, हा 1 कुठे मॅप होईल? या 1 कडे, हा एक possibility. Now second possibility is 1 maps to 2. Third possibility, 1 maps to 3. 1 maps to 4. And the last one is 1 maps to 5. 5 means here 1 maps to here 0, na? Which is equal to 5. Okay, now here what is f of 1 is equal to 1. Here f of 1 is equal to 2. F of 1 is equal to 3. F of 1 is equal to 4. And f of 1 is equal to 5. That means 0. Okay, now what is f of 2? Suppose f is homomorphism. So this f of 2, we can write f of 1 plus 1. That is f of 1 plus f of 1. So that is f of 1 is 1. So 1 plus 1 is 2. Okay, 1 plus 1 is 2. 2 addition modulo 5 is 2. So here f of 2 is 2. Similarly, f of 3, we can write f of 3 is equal to 5. That's again f of 1 plus 1 plus 1, which is equal to f of 1. Why? Because f of f is homomorphism. So f of 1 plus 1 plus 1, we can write this f of 1, f of 1 plus f of 1. So here image of 1 is 1. So here 1 plus 1 plus 1, which is equal to 3. Addition modulo 5 is 3. Okay, any doubt? Similarly, f of 4 is equal to?
No, sir.
4. F of 0 is equal to 0.
4.
Okay. Now tell me the image of, if 1 maps to 2, then f of 2 is, f of 2 is equal to f of 1 plus f of 1, which is equal to 2 plus 2 equal to 4. 4 addition modulo 5 is 4. 4. No. So now 2 plus 2 plus 2, 6. 6 addition modulo 5, 1. 8 addition modulo 5. Okay, 10 addition modulo 5. कळते कसे येते?
3.
Okay. Now 1 maps
0.
to 3,
Yes.
then 2 maps to 3 plus 3 is 6. 6 addition modulo 5, 1. Okay. 3 plus 3 plus 3, 3 times 9. 9 addition modulo 5. Okay. Now 12 addition modulo 5.
4.
प्रत्येक कसे मैपिंग कसा लगाला? f of 1 plus
2.
f of 1 plus
2.
f of 1 plus f of 1. That is 3 plus 3 plus 3 plus 3. 4 times addition of 3. So that is 12 addition of 2. Okay. 3 5 is 50. 15 addition modulo 3 is 5 is 0. Okay. Now 8 addition modulo. F of 1 is 8. 4 असेल. F of 2 काय असेल 8 असेल. Okay. 8 addition modulo 5. 12 addition modulo 5 2. 16 addition modulo 5
3.
1. Okay. 20 addition modulo 5 0. Okay. Now f of 1 0 असेल तर f of 2 पण 0 असेल ना 0 0 0 0 म्हणजे हा तुमचा आयडेंटिटी मॅपिंग okay and this one is 0 okay 0 ट्रान्सफॉर्मेशन ऍडिशन ट्रान्सफॉर्मेशन okay म्हणजे हा 1 मॅप्स टू 1 अजून कुठे 1 मॅप होते का नाही okay so all these are functions such as that all are homomorphism that is f of x is equal to x f of x is equal to 1 म्हणजे काय तुमचा 1x ना yeah 1x f of x 1 maps to 2 that means f of x is equal to 2x f of x equal to 3x f of x is equal to 4x and f of x is equal to 0x that is 0 transformation these all are homomorphic function any doubt up to here okay now the next question okay let phi is the function from z12 to z3 okay be the homomorphic function homomorphism okay suppose phi is the homomorphism such that the mapping is given to us such that the 1 maps to 2 then find first find the kernel of phi okay suppose this one is k find the kernel of phi what is kernel phi collection of those elements belongs to domain which maps to 0 element of codomain is it correct okay. Now, second one list the cosets list the cosets z12 okay divided by kernel of phi that is k showing the element showing the element in each coset each coset okay so we have to find the cosets of k in z12 okay g by h h is the normal subgroup of g then cosets of h in g are nothing but what is equal to कसा असतो साइड a plus h if binary operation is addition where a belongs to g na so this is the cosets of h in g okay so here you have to find the g is z12 and h is what kernel phi is always normal in g so here k is normal in z12 so we have to find that the cosets of k in z12 okay तो सेट कसा असेल तो डिफाइन करायचा and third one give the correspondence between give the correspondence between z12 upon kernel of phi okay by the first fundamental theorem first isomorphic theorem z12 upon kernel of phi is isomorphic to काय म्हणतो आपण z3 okay domain and z3 म्हणजे याच्यातला कुठला एलिमेंट हा कोणाला करस्पॉन्ड आहे कोणाला okay by first isomorphic theorem we see that this z12 upon kernel of phi is what isomorphic to z3 isomorphic चा अर्थ काय म्हटलंय एलिमेंट फक्त दिसायला वेगळे असतील या सेट मध्ये आणि या सेट मध्ये ओके all those properties satisfied by this group also satisfied by this group ओके, काय सांगितलं मी, त्याच्यातले एलिमेंट तर असं दिसत असतील. ओके, ह्याच्यातले एलिमेंट कसे दिसणार? ओके, इज इट करेक्ट? फक्त दिसायला वेगळे असतील. ओके, एनी डाऊट, एनी क्वेश्चन? ओके, म्हणजे या सेटमध्ये आणि या सेटमध्ये कोणता एलिमेंट कोणाला करस्पॉन्ड आहे हे सांगायचं. ओके, एनी डाऊट, एनी क्वेश्चन? That phi is the function Z2 to Z3 with homomorphism such that phi of 1 mapping the leg is equal to 2. Find the kernel of phi, which is equal to 2. Find all the cosets of K in Z12 and give the correspondence between Z12 upon kernel of phi and Z3. Okay, now look at it. Okay, and last question by the map. By the map, question something like give the correspondence between Z12 upon kernel of phi and Z3 by the map psi described in first isomorphic theorem. Okay, answer. Okay, first write down what is Z12. Say Z12. कोणकोणते एलिमेंट आहेत Z12 मध्ये? 1 2 3 4 5 6 7 8 9 10 11 12 means 0. Okay, is it correct? Okay.
Yes.
Now what is given to us? Phi of 1 maps to 2. Okay, if you apply pi on this one, so we get the image element of Z3 which is equal to 2. Okay, now here also given that phi is homomorphism, that is phi of 1 is equal to 2. Now tell me what is the phi of 2? Let's see which phi of 2. Phi is homomorphism, that means 1 plus 1, which is equal to phi of 1 plus phi of 1, which is equal to 2 plus 2, that is equal to 4. But what is operation here? Addition modulo 3. Hence 4 हा तुमच्या Z3 मध्ये आहे का?
Nice. One.
नाही ना, मग तो addition modulo 3 कधी येईल? 1. So
One.
phi of 2 is equal to 1. Now tell me what is the value of phi of 3?
0.
Very good. Phi of 3 is 0. Okay, कसा आला हा? Phi of 1 plus इथं 3 असेल. Okay, इथं phi of 1 plus 1 असेल. Okay, again इथं phi of 1 येईल. So 2 plus 2 plus 2, that is 6. 6 addition modulo 3 is 0. Okay, any doubt?
No, sir.
Okay, now tell me what is the value of phi of 4?
2.
Very good. Phi of 4 is equal to 2. Phi of 5?
1.
1. Very good. Phi of 6?
0.
0.
पहा आता कसे येतात पहा याचे इमेज. 210, again 210, again 210, again 210. ओके, ते एका सिक्वेन्स मध्ये जाते. 210, 210, 210, 210. Okay, so this is the phi image of 7, phi image of 8, phi image of 9, phi image of 10, phi image of 11, and this is phi image of 0. Okay, now first we have to find the kernel of phi. Okay, first one, A. What is kernel of phi? Kernel of phi, the collection of those elements of domain. What is domain? Z12. Such that phi of x is equal to 0, where 0 is the identity of codomain. Okay, 0 is identity of codomain. That means Z3. Z3 identity काय ते 0. Okay, now tell me what is the kernel of phi? Z12 मधले असे एलिमेंट घ्यायचे जे phi of x मला 0 मिळतील. आता झिरोला मॅप होणारे कोणकोणते एलिमेंट आहेत? हा मॅप होतोय
3,
झिरोला,
6.
हा मॅप होतोय झिरोला, हा मॅप होतोय झिरोला. This one maps to 0. Is it correct?
Yes.
Yes.
Okay. So what is the kernel of 5? 0, 3, 6, 9. Any doubt?
No.
No,
Order
sir.
of
No, sir.
K. This is K. Capital K is equal to kernel of 5. So order of capital K is equal to what? 4. Okay. Now we know that if G is the group and H is the normal subgroup of G, then order of G by H is equal to what? Order of G divided by order of H. I like it. Okay. Okay. Now wait a minute. Here order of Z12 divided by K is equal to what? Order of Z12 divided by order of K, which is equal to 12 upon 4, that is equal to 3. This implies Z12 upon K, order of Z12 upon K is equal to 3. So the cosets of K in G contains how many elements? या जो हा जो सेट असेल Z12 divided by K कसा असेल हा दिसायला A plus Z12. Okay, such that A belongs to A plus A plus capital K, such that this A belongs to Z12. Is it correct? G by H, sir. Suppose G by H कसा लिहितो आपण असे A plus H such that A belongs to G. Here what is G? G is Z12. Z12. What is H? H is kernel of 5. It is A. Okay, any doubt? Z12 upon K is equal to A plus K such that A belongs to Z12. Okay, now take A is equal to 1, which is belongs to Z12. Okay, then Z12 upon so that is this one 1 plus capital K. Now tell me this, add 1 to each and every element of K. काय K कुठे आहे तुमचा? K 0, 3, 4, 9, 6, 6, 9. मग काय केल्यानंतर 1, 4, 7, 10. Is it correct? So 1 plus K is equal to what?
Yes.
1, 4, 7, 10. Okay, now if A is equal to 2, okay, कुठला घेतला हा Z12 मध्ये हा काय येईल then 2 plus K is equal to 2, 5, 8, 11. Okay, now
11.
0 है ना, 0 plus K. Suppose A is equal to 0, this belongs to Z12. 0 plus K, 0, 3, 6. Fast case, ना?
0, 3,
Okay,
6,
so
9.
this is 0 plus K. This is 1 plus K is equal to 1, 4, 7, 10. This one is 2 plus K is equal to 2, 5, 8, 11. Okay, now A is equal to 3 now. Okay, belongs to what? Z12. So 3 plus K is equal to Kyle 6,
3,
9,
6, 9,
12.
12.
0 na?
12.
But which is equal to what? 0 plus K. Okay, is it correct? आता 4 plus K कोणाला येईल? Equivalent
1.
हा येईल
1.
1 ला. Okay, 5 plus K 2 ला येईल. Okay, if
2.
A 6 plus K again Zero like
Zero.
equivalent. Okay. 7 plus k,
Zero.
I 1 plus k. 8
1.
plus k, 2 plus k like equivalent. Okay. कळतंय आता काय म्हणतोय, काय सांगतोय?
हाँ सर.
Okay.
Okay.
That means this set contains फक्त हे तीनच डिस्टिंक्ट एलिमेंट असतील ना. आपण हा जेव्हा सेट लिहितोय Z12 अपॉन के, प्रत्येक एलिमेंट नाही लिहू शकत ना असं. Z12 upon K is equal to what? A plus capital K such that A belongs to Z12. Okay, that is Z12 upon capital K is equal to 0 plus K, 1 plus K, 2 plus K, 3 plus K, 4 plus K, up to so on 11 plus K. Okay, but here 0 plus k is equivalent to 3 plus k. 1 plus k is equivalent to 4 plus k. Okay, 2 plus k is equivalent to 5 plus k. Okay, any doubt? In the set 3, एक element आपण एकदाच लिहितोय. Okay,
Sir.
that's why हे पुढचे element घ्यायची गरज नाही. Okay, distinct element लिहितो ना आपण एखादा सेट लिहिताना काय लिहितोय? Z is equal to, समजा suppose this is set G. त्याच्यात 1 plus 1 plus 1 असं लिहितोय का आपण सेट इज इक्वल टू सिंगल टर्न असंच लिहितोय ना, एक एलिमेंट एकदाच लिहितोय आपण. ओके, सो हियर Z12 upon K contain how many elements? 1, 2, 3. That is the order of Ala. Okay, any doubt? So the cosets of K in Z12 contain 3 elements, that is 0 plus K, 1 plus K and 2 plus K. ओके, किती एलिमेंट आहेत या ग्रुपमध्ये? 3 एलिमेंट.
3.
ऑर्डर काय आहे? प्राइम ऑर्डर. प्राइम ऑर्डर असलेला प्रत्येक ग्रुप कसा असतो? म्हणजेच हा कोणाला आयसोमॉर्फिक असेल? त्याच्यात किती एलिमेंट आहेत? 0, 1, 2. पहा, दिसायला वेगवेगळे आहेत एलिमेंट, पण हा सगळं कसा आहे? हा सायकलिक असेल, हा ही सायकलिक. इथे 1 plus 2 असेल, इथे हा आणि हा दोघांची ऍडिशन असेल. ओके, आता पहा. So here the Z12 upon K, that is Z12 upon kernel of phi contains 3 elements. This is the D. Okay, now find the kernel of phi first. Find out क्या, list the cosets from list करें. Third one, give the correspondence between Z12 upon kernel of phi and Z3 by the map psi described in first isomorphic kernel. Okay, we define the map psi from कुठून कुठे define केला आपण? Z12 upon kernel of phi, that is K. Okay, to what? Z3 कसा define होईल तो? So here, इथून इथे डिफाइन केला किंवा इथून इथे डिफाइन केला, हा दोन्ही आयसोमॉर्फिक असल्यामुळे इफ A is isomorphic to B म्हणा किंवा B is isomorphic to A, दोन्हींचा अर्थ एकच. ओके, आयसोमॉर्फिक म्हणजे 1 1 ऑन टू फंक्शन आहे, म्हणजे तिथे काय होणार? इन्व्हर्स एक्झिस्ट होईल. सो हियर सी psi is the isomorphism from Z3 to Z12 upon K such that psi of x is equal to kx. ओके, इथं जर मल्टिप्लिकेशन, बायनरी ऑपरेशन इज काय? मल्टिप्लिकेशन. जर ऍडिशन असेल तर k प्लस एक्स आला असता. ओके, एनी डाऊट? असाही घेऊ शकतो आपण, k प्लस एक्स. ओके, व्हॉट इज Z3? Z3 इज इक्वल टू 0, 1, 2. Okay, what is Z12 upon K? आता फाइंड केल्यानुसार 0 plus K or K plus 0, we can write K plus 0, K plus 1 and K plus 2. कसा मॅप होईल हा? phi of input domain, phi of 0 is equal to K plus 0. Phi of 1 is equal to K plus 1. Phi of 2 is equal to K plus 2. Okay, any doubt? Okay, so here the 1-1 correspondence between Z12 upon kernel of phi and Z8 is given by phi of x is equal to k plus x or x plus k or k into x. The solution. Okay, any doubt? Okay, also next question. Also next
No,
point. Now here the 0 plus k. काय होता तो बस 0 3 6 9. Suppose this is k naught. त्याला नाव दिलं k naught. Okay, which is equal to काय हा 3 plus k like 12, which is equal to 6 plus k like 12, which is equal to 9 plus k like 12. Okay, हे सगळे सेट सेम होते. 1 plus k, which is equal to 1 4 7 10. Suppose this is name k1. This is equal to 4 plus k, which is equal to 7 plus k, which is equal to 11. No, sorry, 11. 10, sorry, 10 plus k. Okay, now 2 plus k is equal to 1, 2, 5, 8, 12. 8 and 11. No?
11.
Yes. K2. So this is equal to 5 plus k is equal to 8 plus k is equal to 11 plus k. ये सगळे चेक कशा असतील अशा. ओके आता पहा 2 plus k is equal to 2 5 8 11. ओके आपने पॉइंट लिखा था a plus h is equal to h. This implies and imply a belongs to h. Okay, पहा what is k? K is equal to 0 3 6 9. Okay, now a plus h is equal to h assume that a belongs to h. Now check a is equal to 0. What is a is equal to 0? Then 0 plus k. ह्याच्यातच एलिमेंट घेतला. Okay, a belongs to h घेतला. Now we have to do that a plus h is equal to h. What is k plus 0? Add 0 in each and every element of k. काही राहते 0 3 6 9 which is equal to k. आला का 0 plus k is equal to k. Okay, any doubt? Any doubt up to here? If a plus h is equal to h असेल, then imply
No,
a
sir.
belongs to h. That means if you have taken a belongs to h, this implies this statement is correct. हाँ, the a belongs to a is equal to 0 घेतलं. 0 plus क्या है? क्या? Okay, now what is take a is equal to 3 now. What is 3 plus k? 3 plus k कोणाला equivalent आहे ते म्हटलं? हाच आहे ना सेट. That is equal to k ना again. Similarly, 6 plus k again is equal to k. 9 plus k is equal to k. अच्छा लड़ो क्या होगा? समझते ना व्यवस्थित है? Okay.
Oh, sir.
So this is the solution of this problem. Any doubt? काही डाउट्स असतील तर विचारू शकता. सागर जालनापुरे आहेत काय? जालनापुरे सागर नाही. सांगताना ऐकत नाही आणि पुन्हा विचारतात. ओके नेक्स्ट प्रॉब्लेम इज नेक्स्ट. Any doubt up here? Okay, so we'll move towards next point.
No, sir.
ऐकत
No,
जा.
sir.
Okay,
I me.
let capital G be a group. Okay, then for any non-empty subset, for any non-empty subset of G, subset of G. First one, first statement. N of S, normalizer of S, okay, is subgroup, is the subgroup of G, capital G. Further, okay, further, for any group, for any group H of okay, yes, absolutely. What is the statement first? Time and time. Let G be a group, then for any non-empty subset S of G, normalizer of that set S is the subgroup of G. Okay, what is the normalizer of S? The elements belongs to G such that it's commute with each and every element of S. Okay. Further, this result is true for any group also. If H is the group of G, the normalizer of H is again subgroup of G. ओके हा सेटला रिजल्ट ट्रू होत नाहीये तो ग्रुपला ही ट्रू होतं. Okay, if S is the subset, non-empty subset of G, then normalizer of S is the subgroup of G. Further, for any group H of G, this result also holds. That means N of H is the again subgroup of G. Now the second statement, normalizer of H, that is N of H, is the largest subgroup, largest subgroup, largest subgroup of G in which H is normal, in which capital H is normal. That is, H is normal subgroup of N of H. It is the subgroup of G. This guy N of H हा असा subgroup आहे, largest subgroup in which H is normal. म्हणजे या याच्याला कंटिन्यू करणारा हा सगळ्यात मोठा सबग्रुप. ओके, ह्याच्यापेक्षा मोठा N of H पेक्षा मोठा कोणताही सबग्रुप होत नाही, एक्झिस्ट होत नाही. ओके, H is normal in that group. Okay, so here N of H is the largest subgroup of G in which H is normal. That is, H is normal in N of H, which is subgroup of G. And the third one, if capital K, okay, is subgroup of normalizer of H, then this H, okay, this H is normal in KH. Okay, product of two subgroups. If suppose this H is normal in normalizer of H, then this H is normal in K into H, product of two subgroups. Okay, it's a segment over here. Easy I to prove. Okay, first we have to prove that for any non-empty subset S of G, N of S is the subgroup of G. Okay, first, write down all the things first. Any doubt in the statement? Any doubt? कोणाचं तरी काहीतरी टॉपिक होतं नॉर्मलायझर ऑफ सेट. कोणाचा तर काल कोणी फोन केलं होतं? आहेत ते सेमिनार आहे म्हणून सांगितलं, नॉर्मलायझर ऑफ ग्रुप माझा सेमिनार आहे. आहेत का ते नाव काय त्यांचं? Given that S is non-empty subset of G. Okay, first, suppose S is non-empty subset. त्याचा काय त्या S मध्ये काहीतरी एलिमेंट आहे. ओके, non-empty असं. S is non-empty subset of capital G. Then, by the definition of normalizer of S, what is the definition of normalizer of S? Collection of those elements belongs to G which satisfies this condition. Which one? x into capital S into x inverse is equal to, yes, capital S. Okay, that means x into small s is equal to small s into x for all small s belongs to capital S. म्हणजे ह्या कॅपिटल एस मधल्या प्रत्येक एलिमेंटला काय व्हायला पाहिजे, तो कॉम्युट व्हायला पाहिजे. याचाच अर्थ काय? Okay, any doubt? The normalizer of set is equal to collection of those elements belongs to the set group G such that x into x inverse is equal to capital S. Okay, now here the normalizer of a set, yes. Okay, this one is capital S. Normalizer of a capital S, n of S is non-empty. Why? Now look at it. If small e belongs to G, okay, identity element of that group G belongs to the set G, and the identity element E is always commit each and every element of set S. Okay. Identity element E हा काय होतोय? याच्या प्रत्येक एलिमेंट S हा काय तुमचा? सपोज दिस वन इज G. ओके, दिस इज यस सबसेट आहे, हा सबसेट. ओके, त्याच्यातले एलिमेंट हा तुमच्या G मधल्या एलिमेंट मध्ये असतील. ओके, S मध्ये एलिमेंट आहे म्हणजे G मध्ये ते एलिमेंट आहे. Okay, and where E, suppose this E is called with each and every element of this group. Okay, that means also this commit with each and every element of S again. Okay, so here E belongs to G and E into S into E inverse is equal to S. Okay, E inverse is E. So this implies, okay, E satisfies this condition. That means E belongs to normalizer of that set. Any doubt? Any doubt up to here? Now you will cut a selection. So that means this is not equal to 5. कळत नसेल तर विचार, आपण शांत नका बसू, मला काही समजणार नाही. Okay, so E belongs to n of S is not empty. Okay, so this implies normalizer of any set S is non-empty. Now we have to prove that. First one, to prove that normalizer of S is subgroup. Subgroup of G. Okay, that is how to prove the subgroup. That is, we have to prove that if x and y belongs to normalizer of that set, then x inverse y. Okay, कसा prove करतो? A and B belongs to H. If AB inverse belongs to, or A inverse B belongs to H असतील तर काय होईल? हा H हा subgroup of G. Okay, so here x and y belongs to n of S, then x inverse y belongs to n of S. That is, we have to prove this one. Okay, now let x and y, these are the two elements belongs to normalizer of S. This implies, by the definition of normalizer of S, आधी नॉन एम्प्टी का दाखवलंय? हा, नॉन एम्प्टी आहे याचाच अर्थ काय, त्याच्यातून आपण एलिमेंट घेऊ शकतो x and y. Okay, so we can take x and y belongs to normalizer of S. Okay, if x and y belongs to normalizer of S, so it satisfies this condition. Which one? X, capital X inverse is equal to S, and small y, capital S, small y inverse is equal to capital S. Okay, they don't condition satisfied. Now we have to show that X inverse into Y belongs to normalizer of S. Consider X inverse Y into capital S into X inverse Y bracket inverse. Okay, हा element आपल्याला find out करायचा, which is equal to, now look at here, this is X inverse as it is, Y is as it is, capital S as it is. A B inverse is equal to what? B inverse into A inverse, na? So here, applying this rule, we get this is Y inverse, X inverse the inverse. Okay, so this is equal to X inverse. This one is Y into capital S into Y into inverse of inverse itself X. Okay, so this implies, now what is Y S Y inverse? Capital S. Now putting the value of this one, X inverse into capital S into X. Okay, now this one, value of this one is again
Yes.
X. Okay, so this implies X inverse Y into capital S into X inverse Y bracket inverse is equal to capital S. Okay, so this implies X inverse into Y belongs to, आता हा एलिमेंट काय केला, हा सॅटिस्फाय केला कंडिशन, म्हणजे हा एलिमेंट कशात जाईल, बिलॉंग्स टू normalizer of S. Thus, we get X and Y belongs to normalizer of S. So this implies X inverse into Y belongs to normalizer of S. This implies normalizer of S is subgroup. Any doubt? Of capital G. हा झाला तुमचा first statement. Okay, and also further for any group H of G, म्हणजे normalizer of S, S हा सेट साठीच नाही तर त्या ग्रुप साठी ही ट्रू होते. Okay, so further write down. Subgroup हा सबसेट असतोच की. Okay, every subgroup is a subset. So this is true for any group also. So further, the result also true for any subgroup of G. Any doubt? Kind doubt is the result. Since what is the result? Every subgroup of every subgroup is a subset, na? It's subset of G. Okay. Now the second one. Now we have to prove that n of H is the largest subgroup of G in which H is normal. To prove that, second one, normalizer of H is what? Is the largest subgroup of capital G in which capital H is normal. Okay, that is, suppose this is the group G. Okay, this is the group G. Then this is the normalizer of H. Okay, is this subgroup of G, and this one is suppose H. Okay, so H, normalizer of H is the largest subgroup of G in which H is normal. That means H is normalizer of H, which is subgroup of G. Okay, म्हणजे या normalizer of H पेक्षा कोणताही असा एक मोठा subgroup exist होत नाही. Suppose this one is again one subgroup. Suppose this one is K. So there does not exist K such that this H is normal in K, which is subgroup of C. त्याचा अर्थ काय, म्हणजे या n of H पेक्षा मोठा कोणताही K एक्झिस्ट होत नाही, such that H is normal in K, is the subgroup in G. म्हणजे काय, हा n of H सगळ्यात मोठा आहे तुमचा. Okay. Right. So we have to prove that H is normal in n of H, which is the subgroup of G. Okay. Now prove. Let capital H be subgroup of G. Capital H is a subgroup of G. Okay. This is subgroup of G. Okay, this one is normalizer of H. Okay, then H is what subgroup of G? Then for any small h belongs to capital H, that implies H into capital H into H inverse is equal to capital H. Okay, that means H into any element of capital H into small h inverse again is the element of capital H. Okay, that is the group itself is normal in H. H is normal in H, yes. Okay, so for any H is the subgroup, any subgroup H of G, any element small h belongs to capital H. This implies this condition holds H capital H into small h inverse is equal to capital H. So this implies this small h is the element of normalizer of H. Okay, a type of the small h are condition satisfied. That means this h belongs to normalizer of H for all small h belongs to capital H. Okay, all प्रत्येक element h हा काय करते हा satisfy करते, that means h is belongs to normalizer of H for all h belongs to capital H. So this implies h हा capital H मध्ये घेतलाय, h हा गेला कुठे normalizer of H. That means H is what contained in normalizer of H. Normalizer हा मोठा आहे आणि H हा लहान. Okay, so here the H is contained in normalizer of H. Okay, any doubt up here? Any doubt है क्या? Okay, now let there exist K such that H is normal in K. Okay, there exists K such that H is normal in K. असा एक group exist होता है. There exists a group K of G such that K is a subgroup of G such that H is normal in K. म्हणजे काय हा H ला कंटेन करतोय, कोण करतोय K. And we have to prove that this K is contained in normalizer of H. And the statement, what is the meaning of this statement? We have to prove that n of H is the maximum. Okay, n of H is the largest subgroup of H. Okay, if there exists a K such that H is normal in K, तर तो K कसा असायला पाहिजे ह्याच्यापेक्षा लहानच असायला हवा. Okay, any doubt? Now, suppose small k belongs to capital K. Okay, take any element of capital K. That implies here the H is normal in K. That implies this small k into capital H into small k inverse by the definition of normal subgroup. One the basic concept, which is equal to capital H. This implies, okay, now this k into H into k inverse belongs is equal to H. Then this small k belongs to normalizer of H. Okay, हा k कोणाला कॉन्व्हर्ट करतोय H ला कॉन्व्हर्ट करतोय capital H. That means k belongs to normalizer of H. What is normalizer of H? पहा पुन्हा. Normalizer of H, the collection of those elements belongs to G that shows this condition. Okay, here the small k holds this condition. K into H into K inverse is equal to H. That means K belongs to normalizer of H. So this implies if taken K belongs to capital K and we get K belongs to normalizer of H. That implies capital K. प्रत्येक यातला प्रत्येक एलिमेंट काय होतो ह्याच्यात जातो. So here the capital K contained in normalizer of H. Okay, म्हणजे K हा कसा आहे तुमचा normalizer of H मध्ये contained आहे. Hence K is capital K is contained in normalizer of H. Okay, so that means this implies normalizer of largest subgroup of capital G in which H is normal. Okay, that means काय बघेल आपण जर कोणी okay जर कोणता के एक्झिस्ट होत असेल okay if suppose there exists any k such that H is normal in K, so that K belongs to that K contained in normalizer of H. That means this normalizer of H is the largest what largest subgroup of G in which H is normal. Any doubt up to here? Now we have to prove that first step. Okay, what is the third one? Second step 24, and now that is the largest subgroup of G in which H is normal. Now, third one, if K is the subgroup of normalizer of H, then H is normal in KH. Now, write down first, third one, given that, okay, K is subgroup of normalizer of H, and we have to prove that H is normal in P. We have to prove that H is normal in KH now. KH into H denotes normalizer of H. The K into H. Okay, you can note and since K is the subgroup of normalizer of H. So K is contained in normalizer of H. Subgroup is only to contain the kernel. So this implies small k, capital H, small k inverse is equal to capital H. Why? Because K is contained in normalizer of H. For small k belongs to capital K. For all small k belongs to capital K. Okay. By the definition. Why? Because K is subgroup of N of H. Okay, that means K is contained in N of H. Okay, suppose this one is N of H, normalizer of H, and this one is K. So every element of K conjugate with each and every element of normalizer of H, that is H. Okay. So this implies small k into capital H is equal to capital H into small k. Okay, post multiply by k. So here k inverse into k is E. So here H into k is H. Okay, so this implies capital K into H is equal to capital H into K. Okay, so this element for all small k belong to capital K. प्रत्येक एलिमेंट हे जर ट्रू असेल तर काय होईल कॅपिटल के इंटू एच इज इक्वल टू एच इंटू कॅपिटल के ओके एंड वी हैव व्हाट वी हैव दिस KH K into capital H is what subgroup of normalizer of H. Okay, K is the subgroup of normalizer of H. So multiplying this KH is equal to what? K into H product of two subgroups. K into H is again subgroup of N of H. What is the reason? Since H is normal in NH, okay, and K is subgroup of normalizer of H, then the product of these two one is subgroup of N of H. Okay, we have H is normal in normalizer of H, and K is subgroup of normalizer of H. That means K into H, product of this one, K into H is what subgroup of normalizer of H using the result. Okay, now what we have K into H is what subgroup of normalizer of H. Now by result. Which result? Direct result use kala. Okay, it's good one. If suppose H is the normal in N of H. Okay, and K into H is subgroup of normalizer of H such that H is contained in KH. It's contained in normalizer of H. Then H is normal in K into H. Okay, Kaiser, if H is normal in NH, KH is the subgroup of NH. Okay, आता आपल्याकडे आहे result. Now here we proved KH is the subgroup of NH. Okay, such that what we have? H is contained in KH is contained in normalizer of H. Okay, K is contained in normalizer of H. Okay, so K into H again is contained in normalizer of H. So this H is normal in H. So this implies capital H is normal by this one. K into H. Okay, hence the proof. Okay, any doubts up to here? I doubt us to each other. Okay, so here we prove three statements. Let G be any group for any non-empty subset S of G. Normalizer of H is what? Subgroup of G. Okay, and the result is true for again any group, for any group. And N of H is the what? Largest subgroup of G in which H is normal. And K is subgroup of N of H, then H is normal in H. Okay, any doubt up to here? Right out. Okay, wait.